So welcome to Algos and Pen, Season 4, Episode 2, Universal Lucky Charms. You can see right there, that was the introduction to Harry Potter and also the title of our episode, which is Universal Lucky Charms. So before I get to the episode tonight, just want to talk about something rather cool. So back in like MLK weekend, I hang out with my Roomie Graham, and we had very great fun with regards to Universal Studios. So without further ado, I'm going to show you guys first the episode content. So it's shipping up in Boston or Orlando, depending where you are, via Roomiegram, and of course Tableau. That is correct. Tonight's episode, we're going to jump to a completely different area for algorithms, analytics. This episode is dedicated tribute to amazing St. Patrick's Day tradition of enjoying good food and, of course, some drinks and beer with friends, cheering hard for Boston Celtics for banner 18, and a nice Universal Studios throwback to my BU Roomie Graham visit. So here's a Never Have We Ever game played by me and Graham. So Never Have We Ever is a really basic game. It's basically every time somebody has not done something that the prompt is shown, you take a shot of a drink, in this case, Duff beer. So yeah, it's very important that we enjoy the episode and, just chillax, enjoy some drinks, and, be good. So the explanation why the last episode I had shut down comments, it's not because of partner reasons, Valentine's Day reasons, because I was showing a minor on YouTube, Celine Tam. So due to that reason, I had to shut down comments for privacy reasons. However, for episodes going forward, there's no more minors to be shown, so I think we'll be all good. So let me first show you the full game that me and Graham played, and then we're going to get to the episode content. And also today, earlier this afternoon, actually, during my work break, I made a beautiful cucumber salad, which is pretty delicious. It's very easy, very good. There's no cooking required. I also made little shorts with Graham as well, the Duff beer, a beer for me, a beer for you. That's a great little Simpsons reference. So tonight's episode is primarily focused on the three Universal attractions, Marvel, Simpsons, and Harry Potter. Or, if you want to be more cliche, the Wizarding World. So why is tonight's episode called Universal Lucky Charms? Because, of course, Universal Studios, Florida. And it's also talking about lucky charms, stream vectorization, being able to use Tableau, and even here at work, I have to use Tableau for analytics. Tableau could get a little bit tricky to understand, so I'm going to give you guys a bit of a heads up. Make sure you know how to autosave Tableau really well. So without further ado, here is the movie that me and Graham have from our little drinking game. Enjoy.
Hey guys, welcome to Universal Studios Florida. Here's my roomie Graham.
Hey guys.
So we're gonna play a game of Never Have We Ever feat Harry Potter, Marvel Studios, and also Simpsons.
Yeah.
So far, Graham, how do you like the theme park?
It's really good. We've had a lot of fun doing rides and going into different shops and trying all sorts of foods that you only thought existed in cartoons. Well, you can just buy them right here.
Such as the old Duff beer. So basically gonna play Never Have We Ever with these Duff beer shots.
Exactly.
So every time we actually say that we have not done something, we take a sip.
Mm-hmm.
So question number one, never have I ever watched all the Simpsons Treehouse of Horror.
Yeah. I don't know the rules. Yes.
So basically,
Never. I have never. Yes.
All right.
Okay.
Yep. Never have we ever
Oh.
read all the Harry Potter books. Okay.
I have.
Oh, wow, nice.
Yes.
Never have we ever watched all the Marvel movies.
We have.
I have not. Never have I ever visited Harry Potter before this place.
I have.
Yeah. Never have we ever dressed up as a Marvel character.
I have technically. I have dressed up with a Black Panther mask.
I've dressed up as well, Black Panther. Never have we ever, either a girl we've dated or we had a significant other, also dressed up as Marvel character.
I have not.
I have. Sarah's dressed up as Matilda White's female Black Panther.
Oh yeah.
Gotcha, bro. All right. Never have we ever failed an OA exam related to Harry Potter, online assessment for coding.
I have not.
Yeah. Never have we ever watched an IMAX movie for Harry Potter, Simpsons, or Marvel.
I think I have.
Yep, I have as well. Never have we ever missed a Marvel, Simpsons movie, or Harry Potter in IMAX. I have.
Have to.
COVID.
Yeah.
Never have I ever actually walked out on a movie before, from either Simpsons, Harry Potter, or Marvel.
I have not.
I have. Harry Potter 6.
Oh, yeah.
Dumbledore died. All right, final question. Never have I ever been to Universal Studios Florida before today.
I have.
I have not.
You have so much to learn, bro.
Of course.
Yeah.
I'm a newbie. Anyway, this is Graham and Jason. Never have I ever. Thank you very much, guys.
See ya.
See ya.
So as you could tell, that was Never Have I Ever drinking game with me and Graham. Now, of course, this stream doesn't have to always have drinking. You can have anything else. You can have, like, truth or dares, 2 lies and 1 truth, whatever. So that's the fun part of tonight's episode. Now we actually got some St. Patrick's, top of the morning drinking out of the way, and some very old fun with our roomies and partners. Let's now actually get to the meat of tonight's episode, or the Guinness. So this is actually quite important to understand tonight's episode, this portion. So we now go to part 2 of tonight's episode, which is a LeetCode problem. So begin with a very basic and important LeetCode problem. The main focus of the episode is learning how to categorize different types of string data, or in this case, universal ride data, Harry Potter spells, or in this case for LeetCode, binary substrings, 0, 1s, in vector format or string manipulation. Then we use Tableau to visualize these categories. So here's a LeetCode problem presented, which I will share in the episode description. As you can tell, this problem is not that simple to understand. You have to think about some edge cases. So if you give you guys exactly 3 minutes, 17 seconds to think about the LeetCode problem once it loads. While I do so, I'll actually talk more about the Harry Potter stuff. So you can see this is count binary substrings. It's pretty nice. I have submitted my solution, but I'm not going to show you what it looks like. I don't want you guys cheating. So yeah, I want you guys think about how to solve this problem. And of course, if you need any help, there's the editorial, but generally this should not be too hard to think about. Think about basically 2 pointers. 1 pointer for the beginning of a substring, 1 pointer at the end of a substring, and see how they match. So while you think about that problem, I'll talk about the Harry Potter. So here's the problem statement. It's called static analysis of spell checker, get it? Formal methods. So Harry Potter has something famous for nonverbal spells, a spell checker. So we use the static analysis to check the correctness of a spell checker which contains each Harry Potter related word and its correct spelling and usage. To make this thing, appropriate for St. Patrick's, we'll throw out any exceptions over unforgivable curses, Avada Kedavra, Crucio, Imperio, those bad curses, or curses that cause bodily harm, i.e. Secum Sempra, from Harry Potter 6, the bleeding curse. So for example, Wingardium Leviosa would be defined as a charm spell that lifts objects, whereas Wingardium Leviosa, get the reference, would be undefined. So we can use any appropriate coding methods, design paradigm, and coding practices in Python to write only pseudocode designed for a spell checker. Then we'll verify correctness of a spell checker. Only then we'll use code to actually double check. This spell checker is considered to be unique and spelled correctly by default. So you guys are still thinking about the LeetCode problem, huh? All right. While you guys still think about the LeetCode problem, I'll get started with the design for spell checker. So let me bust out the old whiteboard, and to make it St. Patrick's style, I'm going to make it very fun. I'm going to draw a big, big box covering the whole whiteboard itself. And the format's going to be green, of course. The whole thing is going to be green. So I'm going to draw another big green box to cover for St. Patrick's. All right, fantastic. So this spell checker thing, it requires a lot of components, right? Wrong. It only contains 3 main components. You'll first, of course, need an input thing. So you need some input for a spell checker. You'll need input. Next, you'll need something called a formal verifier or formal checker. Finally, of course, you'll need the output. And this is where string stuff comes in. So you're going to need the output here. So this is the output. They'll basically have string verification. So while you think about the string verification, what do we really need? We'll need exceptions, of course, right? Try catch statements. We're using Python here. So we have something like try. I didn't want red, I want green, please. Thank you. Try, for example, a spell. And this is pseudocode, by the way, it's not really code. To try a spell. And of course, and this is in Python, so we're going to just do this, try a spell. And accept exception E, which is just a random exception. E.message, unforgivable curse, exiting program. So the real program is actually not that, but it is very similar. You'll see in the real program, I make the message a little bit more comprehensible. So that's your exception. So what do you use for input? So for input, we use something called raw input because we're using Python 2. And for formal checker here, I'm going to put my screen over. For formal checker here, we're going to basically check against a dictionary of spells and definitions, which is very important. Make sure it's not null, the dictionary. And for output, basically say we define it or it's undefined. So there you have it. That's a general design for this thing. That's a general design. So now to get back to the LeetCode problem a little bit. Let me first save this whiteboard. To get back to the LeetCode problem a little bit, let's say we have a string manipulation. So you have a string of 0, 1, 0, 1, 0, 1, 0, 1. So you want to find the count binary substring. So you could do 2 things. You can have a pointer here and a pointer here. And these pointers are going to help you determine the substring. So if the pointers are pointing to the same substring, it's going to actually be null. It'll return nothing. Otherwise, you gotta actually have to compare to each of the values in each substring. So you gotta look at each substring for the binary substrings, group them together. So this is like sort of extreme vectorization. And then finally, for each substring, do the following. You then accumulate the pointer if it's, if found. Otherwise, reset to previous if not found. And that's basically it for the general pseudocode of this thing with like the general details. So we've talked long enough. Let's look at the code. So let me go back to my code. So here's my solution. As you can tell, I have basically a basic check. If S is none or S is empty, return none. They have two pointers and something called the answer, because you want to return the number of non-empty substrings. So if answer equals 0, previous 0, next equals 1, so try and start from the end of a string. Then for the length of a string, I use xstring because I use Python 2 here. If we basically do not have the strings already matched up, you concatenate the groups, you find the minimum of the substring. Then you set the pointers and you use x next to 1, otherwise increment by 1. And then to finally wrap up the solution, return either the answer plus the minimum of the previous or the next. I would submit my code, it should work. It's been a while since I used LeetCode, so should be good. So it's been accepted, it works. So I submit my code and I'm all good. So it's the same code I did before, but it's not self-plagiarism because it's just a general solution. If you look at the editorial, the solution is pretty good. So yeah, you could definitely look at some different codes in terms of like solutioning. So let's get back to Harry Potter. I know it's just a lot of jumping between screens, but it's pretty good. So let me get back to Harry Potter. So before I actually show you how the Harry Potter thing works, I'm going to Vim it. So I'm going to share you guys the Harry Potter screen now. So the Harry Potter screen is pretty simple. This is a program that's a spell checker that uses counting binary substrings two-pointer method to double check if a particular Harry Potter spell is considered valid. For example, in Hermione and Ron, Wingardium Leviosa, that lifts up the feather. If you see Wingardium Leviosa, spell does not work. If it's not valid, we'll return an appropriate definition. If it's not valid, we'll return undefined. If unforgivable curse, it'll cause bodily harm, we'll throw an exception. So you got the spells, you got Wingardium Leviosa, Accio, Expecto Patronum, Lumos, Aguamenti, Homium Revelio, Impedimenta Stupefy, Protego Expelliarmus Reducto Ridiculous. So very basic common Harry Potter spells. We got unforgivable curses, Avada Kedavra, Crucio, and Imperio. Don't use those in real life, please. Harms, you got Exectum Sempra, explosive because it blows things up, and Extendo because you set things on fire. You got the definitions, and to prevent cheating. This is preventing all the definitions, but I don't exactly show all that because you want to, think about the definitions. We basically have the user put in the input, then I mentioned it before, the try statement. So if the input's an unforgivable curse or if it's a harm curse, it's illegal, get the checker to end. If it's also instant of those curses, also it needs to end. Otherwise, for each spell definition, we first check for sorted split input, and then we use the two-pointer strategy. So if the pointer of the spell is the same as pointer definition, we print definition, otherwise return the input. And here's the really basic main. We just basically, run the main and see how it goes. There is one thing though, because I want you guys to really memorize the spells really good, I'm going to make you have the definition printed out however many times the spell has been printed out. That's on purpose. So let's begin. So let's begin something very simple. Accio. It's a summoning charm from Harry Potter. Now if I do this, misspell it. Accio. It's going to be undefined. It's going to exit. Now let's say you're feeling real frisky and you want to just, somebody cost you the bracket on NCAA tournament and you want to really punish that bad bracket person. Or if you're like the, NBA Timberwolves, you really don't like the refs. You want to crucio the refs, right? Sorry, you can't hurt the refs. The refs' lives matter. Also, for Python Harry Potter, you can do the following. You can even do spaces. They'll space check. So for example, Wingardium Leviosa, like I mentioned before, it's going to give you undefined. But if it's Wingardium Leviosa, then you'll be fine, I hope. Yes, as you can see, it's a charm spell that lifts objects. You tried the Incendio, the burning spell, also not going to work, sorry. You try Incendio, the burning spell, it's also not going to work. So you can see this is a really awesome Harry Potter spell checker. I will post the GitHub repo to this code on description for the episode. So now the fun part begins. Tableau. So quiz for you guys, and I'll post it on the chat. What is Tableau, first of all? A, Power BI, which is Power Business Intelligence tool. B, Analytics tool. Or C, tool to visualize analytics items. So I'm going to share the chat screen. So I'm sharing the chat screen here. So I'm sharing the chat screen. So what is Tableau? Is it BI, analytics, or tool for visualize analytics items? If you said C for Lucky Charms, my man or my woman, you are definitely lucky on St. Patrick's. It is absolutely C. And also, speaking of C, go Celtics. So yeah, very important to understand what Tableau is. It's C. It's a tool for visualizing analytic items. So without further ado, let me show you the finale of tonight's episode. A lot of screens here, I understand, a little bit clunky. So pardon me for that. So this is the final part of tonight's episode. Universal Studios Tableau rides. So now we have a good understanding of the string vectors, we can begin using Tableau BI, which is business intelligence tools to visualize the results and learn more about cool rides at Universal Studios here in Florida. To hear some of the awesome rides from Universal Studios, you can see there's some pretty good looking rides. I'm just gonna name a few that I think we could have went, but due to time's restriction, because me and Graham only had one day, well, we had only 6 rides. But and here's a fun fact. When I first came here to the US, I never really wanted to ride. I was very scared because roller coasters are scary. But now that I've got my taste of roller coaster freedom in Orlando here, I'm willing to ride more. You can see that's beautiful Hogwarts Castle right there. I don't want to donate money. Sorry. So there's Hogwarts Castle, there's The Revenge of a Mummy, just quite a few. So I did ride the Despicable Me. I did ride Holly Ride Rip Ride Rocket, which is the most extreme ride, shall I say, from all 6. I also did some good old Jimmy Fallon stuff. I rode the Simpsons ride, which is basically a Mario Karty type of battle with a big panda Sideshow Bob. Spoiler alert. Kang and Toto's Twirl and Hurl just spinning around. And yeah, and Men in Black as well. So if I were to ride Islands of Adventure, I absolutely would choose Flight of the Hippogriff, Hagrid's motorbike, the Velociraptor, Hogwarts Express, and quite a few others. And of course, good old, for Graham reasons, incredible Hulk coaster. So yeah, back to the episode. You can see it's almost over 30 rides. Marcus Smart number, 36 in total. To make our life easier for both our stomachs, since each ride takes a lot out of you, just like a Guinness beer after the St. Patty's hangover, we'll only include the ones that me and Graham rode on. total 6. So for each ride, we'll be putting into CSV representation. We'll include the duration, theme, pricing, and rating in Tableau. We use Tableau to manipulate the data to show the average rating and pricing of each ride. So before we begin with Tableau stuff, I would ask you guys one thing. How many of you guys are actually familiar with Tableau? If you're not, that is okay. I'm also learning on the job. I just started learning Tableau full time like a month and a half ago. As you can see, this thing has no data right now for Tableau because I'm going to be building it for you. That's right, I'm going to be building it during the episode. So you can see Tableau, I built already the view for you at least for the rides. So we got some nice looking viz. Viz is visualization, by the way, for Tableau. So Tableau, you got basically the data window with different tables and names. You also got analytics, which will help you find the grand totals of each of them. So if I would do analytics and find the grand total, I can easily do that with column grand total. And I can calculate the grand total there. So I got the rides for Minions, Hollywood Rip Ride Rocket, The Simpsons, Men in Black, NBC, and Simpsons again. So the trick is going to be the following. How do we get the average of each of these? Well, let me show you. First of all, let's go for our data. We have the name of the ride, which is always going to be the same. We have the theme of the ride. We have duration, which is how long the ride is. The pricing, which is we're going to be manipulating the dollars, and the rating out of 5. We can find the average pricing and rating for the rides, so you can see who likes it the best. First, we're going to do average rating. So for Tableau, what you really want to do is drag a bunch of stuff over. And I don't want to make it automatic, so I'll make it polygon shape so you don't have to worry about the weird looking totals thing. So first, put in the name of the ride. I then put in the theme of the ride. So those are always going to be the same for every one of these. All right, now putting the rating of the ride, which is good, right? And look at that. Tableau gave me something called continuous dimension. You want to turn this into discrete dimension instead. So it's easier to read. And then finally, I'm going to make a duplicate of this rating again. So watch what I'm going to do here. I'm going to rename this to average rating, first of all. And remember, Tableau doesn't allow you to have duplicate pills or like table attributes. So you're going to have to change it up. Then I'm going to do something called create a calculated field. I'm going to rename it average rating space, and basically have the average of rating. That's right. Now it contained an error, right? You don't have the field rating. So you need also the whole thing out of 5. Then you got it. To put here, you put in the average rating for aggregation. And of course, you're going to need this to be discrete. And here's the problem. You haven't solved the average rating, right? It's because you can't use average of an actual rating. So this will not work. What you can do, however, is change the data type, is to change the thing. So you want to change the field itself. So how do you get the average again? Well, you sum the whole thing, divide by total. So you sum the whole thing, you divide by total the whole thing. And I'm going to just copy paste here. Rating, and it's to be out of 5. Now total requires another, so you need to require another sum within the total. So you see Tableau requires a little bit of hocus pocus with the functions. Now let's try it. So you can see it's not yet quite working. It's still giving average rating of 1. However, look at the beauty in Tableau. You can edit the table computation as well. So what's the best way to solve this problem when you don't have the rating working for you? You can do the following. You can remove this for now and do one more thing. So I'm going to cheat a little bit right now and try to solve the answer. Finding average rating. So I'm going to be cheating a little bit and just finding the numbers. This is actually a good way. So it's sum and over count actually, sorry. So this is actually a good way to see whether you've been doing your work correctly. So it's actually sum over count. My apologies. So sum over count instead for average. Now let's see what happens. Okay, it's not discrete yet, so I gotta double check that. All right, there we go. So now the rating average is basically sum over count. And to manipulate it further, I'm going to do the following. To count distinct, you want count D instead. You don't want multiple, you want count distinct. And you could basically replace it here in Tableau. As you can see, the rating is still being calculated as such. So now that we got the rating out of the way, let's try one more thing before I go to pricing. Got it. So one way I could fix this, actually really easy. Find the running sum. So you can find the running sum of this and you need to divide by total to fit the average. Now we get aggregation. So see? So you can see overrating is pretty meh. It's pretty mean. It's pretty mid. Do one more thing. The average rating is pretty mid. It's just 2.5. So wait a minute. Actually, let me do one more thing. The average rating is pretty mid. It's just 3.5. So average rating is okay. This ride is okay. Like it's decent. Of course, this is me being a fool on St. Patrick's. I got to double check my math. So you can see, don't always rely on Tableau math. Make sure your math is actually working out here. So let me just add up the rating real quick on a calculator. This is the first time I was attend history. I actually have to use the calculator to double check my math. So if you don't double check your math right, you're in trouble. Aha, that's very good. So you see what the rating is, right? It's a 4. So my rating is off by a little bit more. There we go. So now my average rating is correct. Awesome. So now let's go under average pricing. So once again, I this time put in the name of the rides. I put in the theme of the rides. I put in the pricing. Now here's what's going to happen. I'm going to be creating a calculated field by duplicating this first, then renaming it to average pricing. Then making a calculated field here in Tableau. Average pricing space. So average pricing, once again, is very simple. It's just the sum of the entire pricing. And you can see Tableau autofill stuff for you, which is awesome. Divided by the count distinct of pricing dollars. This time I'm gonna get it right. So, wait, sorry. Yeah. Yes, that, and that. All right. This time I'm gonna get it right for the pricing. Going to double check the pricing real quick. So you can see I'm still a newbie in Tableau, but I'm still getting the general understanding how to do it right. So let me just double check my math real quick here. Okay, should be 22.7. So let's see what I got. So you can see I made a nice dashboard once I figured this out. A dashboard is really cool in Tableau. You can basically like make a nice little average here. So that's the average pricing. Now remember, I haven't yet changed the numbers. So I'm gonna edit this average pricing instead. So I could do instead sum of that and then times the average I solved. So there you go, there's the average pricing. And now I could put these pieces together. It's like Avengers Assemble from Marvel. I put in basically my title for the Tableau, Universal Studios average pricing and rating. So not bad. The ratings is not bad. 4 rating for a studio is not bad actually. It's better than Six Flags back in Massachusetts, New England area. So that's my title. Of course, if you can't see my title, that's because I made it not floating. So I'm gonna make it floating to make sure I can move the piece in Tableau. So there you go, that's my title. And now to move the pieces over, I'll have the rides put over here. Make this thing floating. So you can see I already made a filter by height duration. By the duration. So make this floating as well. Put this down here. So you can see this is ironically helping me a lot in work. Understand how to put the pieces together, how to get the numbers right. And this is also a filter. You can make this floating. So Tableau is like building a jigsaw puzzle or like, one of those Harry Potter puzzles. So for example, if I want to look at, for example, only 30-minute ride, there we go. There's only Simpsons ride. If it's any other ride, well, tough luck. Then I also add in the average rating over here. So this will also go floating now. I drag this down here for average rating. So you can see I didn't change the colors all that good, right? That's okay. In Tableau, you could directly change the colors. You can just choose the sheet name, make it green, it's for St. Patrick's, change the font, and then make it bold. And there you go, immediately it changes. So that's like the beauty of Tableau. You can like change however you like. However, you have to be careful if you have the desktop version for autosave. I learned a hard lesson here at work. If you do not autosave your version, Tableau will revert back to the old save version, which sort of sucks for everybody. No bueno. And finally, average pricing to wrap up tonight's episode. I'll have a screenshot of this Tableau to post in my GitHub repo. Because you can't directly post a Tableau onto GitHub without like special permission. I can only post a picture of it, but you get the general idea how I make the Tableau. So further information on how to use Tableau more pro, I would suggest a beautiful YouTube channel from somebody who recommended me to use this YouTube channel, and it's very good. So yep, there you have it. You have the filters with Tableau, you have the average rating, average pricing. If you want to make the filters work, you can just add in rating for filters. So Tableau filters are basically allowing you to filter based on some stuff. So you could filter based on, for example, rating filter. So you could filter by all values. You could do a range, which is good. And you can show filter so it actually doesn't, not show up on your thing. And if this looks too weird for you, don't worry. You can change the filter style. You can change the filter style. You don't have to make it this way. So you could change the filter style if you think this is too weird, which I agree. I'd rather would not have it this way. I'd rather do it this way. You can format the filter to be very, very unique. So you can see this is like a sliding filter. So if you want to say anything below a 3 rating, for example, this rating, it's only going to give you Simpsons. If you want to get everything above a 3 rating, well, anything above a 3 rating, you'll have anything but the, can code a Simpsons ride. Then finally, for average pricing, you'll add in the filter again as well from pricing. So filters are really cool in Tableau, but they can be tricky to use. So be aware of like the trickiness. So now we have everything showing, and look at this. My dashboard is a little screwed up. It may have had a little too much St. Patrick's drinking. That's all right. We can remove this container and have the filter show up. So for that to happen, you need to show the filters. So you need filters here. So to have the filter show up, you'll need to do the following. You'll need to actually make sure they show up by reclicking on the pieces that you used. So you have high duration here. So now the average rating has been updated. You can get rid of this. So you can remove and make a new average rating piece with the filter. See? Now there's the filter right there. Go back to floating and drag that boy down. So Tableau is a little bit like, analytics puzzle. It's like one of those Lego pieces you play with puzzles. Then rating, you can easily just drag this thing to floating. Floating is really helpful in Tableau. Like if you don't have floating, this thing is impossible to like fix. So really cool if you have floating here. Really, really cool. Of course, average pricing, this thing is just gonna have to go away. So adios. And then average pricing, go put right back here. So you can see this thing's already been filtered out by pricing. So I'm gonna fix that real quick. So put average pricing down here, then put that filter. Yes, there we go. Put that filter over here, make this floating. So you can see tableaus are like a lot of moving around pieces per se. This is actually really easy version. Like my Word version is like almost like 20 different components per dashboard. That's an actual project. This is like basically a small homework assignment. So you see that the pricing is a little bit off, right? So I'm gonna have to fix the filter a little bit here. So yeah, the average pricing is a little off. That is okay. That is perfectly fine. Do you know why? I could get rid of action, remove. And there you go. All my rides are back. So there we go. That is how you make a beautiful, amazing Tableau dashboard that helps you understand how the rides work in Universal Studios. And don't forget, you can publish this thing. You can publish this thing as Universal Average Pricing and Rating, or Universal Rides Average Pricing and Rating. And you can publish the results. So there you have it. This is the episode. Algos Intent Season 4, Episode 2. Happy St. Patrick's Day and happy Universal Studios Rides Day. Episode 3, we'll get to a little bit more detail with like, various types of analytics, various types of, data, and also really fun to, enjoy Easter. We're gonna have a little bit of egg hunt. And also in concurrent day, I'll have excellent episode with eggs. Until then, have fun, stay safe at St. Patrick's, and continue to have your lucky charms. And one more thing, a little St. Patrick's joke. Joke number 3. If you watched the previous episode from Portion, you'll understand the first 2 jokes. This is more of a math joke. What is the 3-leaf clover plus the number of Celtics banners currently equal to? 317, St. Patrick's Day. All right, see you guys later. Bye-bye.